Of course, metals designed to operate under extreme conditions require even more extreme conditions to fabricate. Some of the major parts had to be shaped in a huge press designed to operate at 1500 degrees Fahrenheit. No such press existed before the need for parts for the Blackbird, so it had to be developed. In fact, the company would go through countless experimental processes in developing the aircraft. Many samples were produced, but the standards to be met were so rigid that a high proportion were rejected. Eventually, parts of reliable strength and integrity were produced, but only after much anxious trial and error and an undisclosed but presumably very large expenditure. Hot forging of the metal in special ovens and presses was only the first step in the processing. These shapes were in effect rough outlines of the parts. The forgings then had to be machined to extremely fine tolerances. The milling machines were advanced designs, tape-controlled early robots with special cutters developed by Lockheed to handle the metal. The cutting fluid was new too. One of its features had to be that it would not corrode the titanium alloy. At each step of this plane's development, everything was either new or specifically adapted, right down to the smallest factors and the most routine processes. Finished parts then moved into sub-assembly processes. Once again, everything was affected. Spot welders had to be specially adapted. Normal tools had to be recast in different metal. Nothing could be taken for granted. Early in the project, Kelly Johnson offered $50 to any one of his staff who could come up with an easy problem to solve. The impish humor barely disguises the core truth in the offer. The designers had to develop the aircraft in the abstract. Their function was, as much as possible, to foresee the implications of each consideration and to follow them until each problem had been identified and solved. They did this without the aid of digital equipment. They did it in the main with slide rules, pens, and bits of paper. There were many problems that arose, either unseen or half appreciated, during the course of early production. And there were flaws in the original A-12s that were dealt with in later models. However, the project ran very smoothly, and the success of the design team has remained a pinnacle of engineering achievement despite the passage of years. Each Blackbird came together as a series of sub-assemblies, with each of the major fuselage and wing components being produced in two sections. In part, this system was developed to save as many man-hours and as much assembly space as possible. Not only would the skin of the plane be subjected to extreme heat, the same applied to the interior. Wiring, which could be relied on at 900 degrees, had to be developed. The problems and solutions went on. Of course, no matter how good something looks in theory, there's always a need for more practical reassurance. A full-scale static test program was conducted. The kind of aerodynamic loads the aircraft would experience in flight were hydraulically forced, and the integrity of the design was studied. Individual components were also tested to destruction. Wheel assemblies were subjected to violent landings and various lateral stresses to test not only the landing gear, but also the tires and the brakes. On the 30th of September 1964, the YF-12, aircraft became the first of the Blackbirds to be presented to the press. It can safely be assumed that no one turned down an invitation voluntarily. In aviation, this was the story of the day. During the presentation, journalists were able to study the plane at close quarters, meet its makers, and watch a demonstration of the aircraft in flight. As with many things about the Blackbird, it's difficult to determine where the plane's original concept came from. Kelly Johnson said that at times the early work began as a long-range interceptor, a role the YF-12 was expected to fill. Johnson was adamant that the submission was a serious contender for a fighter contract and not merely a cover for intelligence planes. The YF-12's obvious external difference was the cutaway of the chines at the nose to accommodate radar needs. To compensate for the loss of stability caused by the cut-down chines, small ventral fins were added under the engine nacelles, along with another larger central fin which was lowered once the plane was airborne. The interception fighter's function is to catch something and shoot it down. When the fighter is flying faster than a bullet, guns are not of much use. Rockets capable of launch at Mach 3 did not exist in 1960. So once again, something had to be invented because of the Blackbirds. The Hughes-developed missile system for the YF-12 would later be reborn as the Phoenix system of the Grumman F-14 Tomcat, because the big black plane was never adopted as a long-range interceptor. As a sole-function aircraft, it simply did not fit the prevailing mood. Many people were astonished at the decision, for if the requirement had been solely for an interceptor, then surely here was the plane. However, politically, it reflected the wrong philosophy. Resentment over the decision lingered for many years.
Now, coming to the YF-12 and the SR-71, I guess perhaps the unique thing, the real unique thing about those two airplanes, unhappily, is we built the wrong one.